Have you ever wished you could just hit a reset button on something? Well, what if you could do that for the human heart? That is exactly what a defibrillator does. Today, we're diving into a piece of technology that, quite literally, holds the power of life and death in its design. So here's our game plan. We're going to start with the problem, a heart in chaos. Then we'll look at the brilliant idea behind the rescue. We'll get familiar with the different types and their parts, walk through the steps to actually save a life, and wrap up with the absolutely critical maintenance that keeps these things ready to go at a moment's notice. To really appreciate this modern miracle, we've got to first understand the electrical storm is designed to fix. So let's take a look at what's going on inside a heart that's in total chaos. I want you to just imagine this scene for a second. Someone collapses. Their heart hasn't just stopped beating, it's gone completely haywire. This is that life or death moment where every single second counts, and a very specific kind of chaos has taken over. And this right here, this is the enemy, ventricular fibrillation. You can think of it like the heart's entire electrical system just short-circuiting. So instead of a strong, coordinated pump, the heart muscle just quivers, uselessly. No blood is flowing, and that's what makes it so deadly. This is the exact state a defibrillator is built to correct.
So, how do you fight that kind of electrical chaos? Well, the concept behind the rescue is surprisingly and beautifully simple. The answer, believe it or not, is basically to perform a hard reboot. The defibrillator sends a powerful, controlled electrical shock straight through the heart. It's so strong that for a split second, it stops all the electrical activity, the chaotic signals, everything. It just flatlines it, giving the heart's own natural pacemaker a chance to wake up and take control again. And this really shows you the transformation perfectly. On the left, you've got that deadly, ineffective flutter. On the right, after the shock, you have the goal, a stable, organized rhythm that's actually pumping blood and sustaining life. It's creating order from chaos in an instant. Okay, so we know the why and the how. But what does this life-saving machine actually look like? What are the key pieces that make it all work? What's so amazing is how this technology adapts to who's using it. You've got the automated ones, the AEDs you see in airports, that literally talk you through every step. Then you have the fully manual ones for doctors, and even tiny implantable devices that act like a personal 24/7 bodyguard for a patient's heart. But no matter the model, the core components are pretty much the same. You've got a screen, which is your window into the heart's rhythm, a powerful battery holding that life-saving charge, and of course, the paddles or pads that deliver it. Every single piece here is absolutely vital. Let's zero in on the paddles for a second. They're way more than just delivery tools. They're the command center. On many of these machines, the buttons to charge up the device and deliver the shock are right there on the handles, putting all that power right in the rescuer's hands for quick, decisive action. All right, we've got the hardware down, but knowing the parts is one thing. Using them correctly, under the most intense pressure imaginable, well, that's what actually saves a life. Okay, before we go one step further, this is the single most important rule. It's non-negotiable. The electricity is powerful enough to stop a heart, which means it can seriously harm a rescuer. So before any shock is delivered, everyone has to be clear of the patient. No exceptions, period. Following these steps, in this exact order, is what makes it work. You apply the gel for a good connection. You dial in the energy level. You get the paddles placed just right. You hit the charge button. You shout clear, loud and proud. And then, and only then, do you press those shock buttons. It's a protocol built for safety and success. Now, here's a really cool innovation in how that energy gets delivered. The older machines were monophasic. They sent a single blast of current in one direction. But modern devices are biphasic. They're smarter. They send the current one way and then they reverse it. This little round trip is way more effective at resetting the heart, which means it works with less energy and is actually safer for the heart muscle. It's a perfect example of making a life-saving tool even better. But here's the thing. A powerful tool is completely useless if it doesn't work at that one critical moment. That's why the maintenance plan for a defibrillator is just as important as its engineering. This is not a device you can just forget about in a corner. Every single day, a quick check is performed. It's simple. You unplug it to test the battery, run a quick low-energy self-test, and the machine itself confirms it's ready to go by printing a little success report. This daily routine guarantees it's always ready. And that standard energy level for the daily self-test, it's typically just 30 joules. That's enough to make sure all the internal charging and discharging parts are working perfectly, but without putting any unnecessary wear and tear on the components.
Now, this right here shows you the safety philosophy in action. When a component fails, whether it's the battery, a cable, or even the main circuit board, the solution is never to try and fix it. The protocol is simple and absolute. You replace it immediately.
And this quote just says it all, doesn't it? For a device that holds a life in the balance, there is zero margin for error. Reliability isn't just a nice feature, it is the entire point. You don't take chances, you replace.
So it kind of leaves us with this final thought. The defibrillator isn't just a clever box of electronics, it's a system built on trust. It's a combination of powerful technology and incredibly strict rules, all designed to work flawlessly when we are at our absolute most vulnerable. And it really makes you wonder, what other technologies are out there, quietly standing by, ready to be our safety net?